Hello everyone, welcome back to another video. Today we're going to be looking at the mechanics section from this paper. Let's give it a go. As always, if you'd like to try it on your own, please pause the video. I'll go to the answer in 3, 2, 1. Question 3.1. The velocity time graph below represents the motion of a car traveling east over a 21-second period. So we have this graph. 3.1.1 says describe how the velocity of the car changes from 15 seconds to 21 seconds. So 15 seconds to 21, that is a 6-second period. And they want us to describe what is happening in that 6-second period. So question 3.1.1, we can see that at 15 seconds, the car is traveling at 30 meters per second. And at 21 seconds, the car is traveling at 0. So the velocity has decreased. So we can say that in the 6-second period, the velocity decreases uniformly right? And then stops. And then the car stops, you could say. Yeah, and then the car stops. Okay, question 3.1.2. Calculate the acceleration of the car from 15 to 21 seconds. So let's just quickly go through how we can get acceleration if you're given a graph. So if you have a velocity time graph and you work out the gradient of that line, then the gradient is going to give you the acceleration. But if you work out the area under that graph, under a velocity time graph, you're going to get the displacement. So if you're going up, you're going to do gradient. If you're going to go down, if you're going to go up this ladder, if you will, you're doing gradient. If you're going to go down the ladder, you do area. So if we have a velocity time graph and we want acceleration, then we work out the gradient. So they want the gradient of this line. So we need 2 points to work out gradient. Let's write out our points. So this point right here is 15 and 30. This point right here is 21 and 0. Let's mark them. So this can be x2, that can be y2, that's x1, that's y1. It doesn't matter which you choose, you still get the same answer. So to answer this question, we'll start by saying that the gradient is the acceleration, and that's equal to y2 minus y1 over x2 minus x1. So y2 is 30, so 30 minus 0 divided by 15 minus 21. And you put that in your calculator, you get an answer of minus 5 meters per second squared. Remember, we should always change our final answer. If it's negative, change it to positive. This is minus 5 meters per second squared east. Therefore, the answer is going to be 5 meters per second squared west. Very important that you remember that, okay? Always change the answer. If it's negative, change it to positive, but change the direction as well. Okay, next one, 3.1.3. The displacement of the car in 21 seconds is 415 meters. Calculate the magnitude. So let's go back here. So they want to know what is the velocity at x. Let's go back here. If they've given us the displacement, that means from the velocity time graph, if we worked out the area, we can get the displacement. So that means the area of this shape, so this entire area here is 415, and they want us to work out the value of x here. Okay, so I'll show you how we can do it. It's not too bad. What we do need to do here though is we should break up this shape. We break it up into separate shapes and then we can work out the area of each, and then sum up that area and get the total. So let's color in this one. Let's make that yellow. Let's call that 1. Then let's color in the next one. Let's go green here. Let us call that 2. And then the next one, we can break up into 2 further shapes. So let's go here. Let's call that 3. And then the last one, let's go with a different color here. Let's call that 4. So the area of all these 4 shapes is 415. Okay, so let's work it out. So the area of 1, so I'm going to write it as A1. Area of 1 plus area of 2 plus area of 3 plus area of 4, that's equal to 415. Now area of 1, that's a triangle, so that's half base times height. So half, the base is not 21. You have to consider now that it's from 15 to 21, so the base is actually 6. So it's going to be half of 6 multiplied by the height. The height is 30. This is the height. The height is 30. Plus area 2 is a rectangle. The base is going to be from 10 to 15, so that's going to be 5. And the height is going to be 30. Plus area 3, that's a triangle, so let's work that out. So that's going to be half. The base is 10. Let's work out the height. The height is going to be this portion here. We know that that's 30 and that's x. So the height is going to be 30 minus x. Okay? So half base times height. The height is 30 minus x. Then plus area number 4. Area 4 is a rectangle. The base is 10 and the height is x. And that's equal to 415. Okay? Then you will simplify and you will solve. And when you solve, you get x equals 5 meters per second. So remember that x represents a velocity, so the units are 5 meters per second. Okay, not too bad once you break it up. Let's move on. Question 3.2. The position time graph for a quad bike traveling north along a straight horizontal surface is shown below. The quad bike starts from rest and moves at a constant acceleration. Okay, so definition, we won't do that right now. You have access to them. 3.2.2, calculate the instantaneous velocity of the quad bike at 6 seconds. So here they're asking for instantaneous because you can't work out the gradient of this line at this level, right? We currently don't have the math to do it. As you go up in the grades, you will learn techniques that you can use to work out the gradient at a point in a curve. So if we have a position time graph and they want the velocity from a position or displacement time graph, if we want to get velocity, we're going up the ladder. So that means we need to work at the gradient, right? So let's look at how we can work at the gradient. So we want it at this point. We want the gradient at this point. And what they've done for us, if they've drawn a tangent line. Now that tangent line touches the curve at that point that we're interested in. So what we can do is we can work out the gradient of that tangent line, and that would be the gradient at that point. All right. So we work out the gradient of the tangent, and that's going to represent the instantaneous velocity. So 3.2.2, remember we need 2 points, right? So gradient, that's going to represent our instantaneous velocity, and that's equal to y2 minus y1 over x2 minus x1. Let's look at our points now. So we know that this point right here, that's going to be 6 and 36. And we can use this point right here. That point is going to be 3 and 0. Let's call this y2. Let's call that y1. Sorry, x2. Let's call this y1 and then call that x1. So we can substitute our points in now. y2 is 36. y1 is 0. Divided by x2 is 6 minus x1, which is 3. And when we solve for this, we get 36 divided by 3, which is 12. 12 meters per second. Right? Now, this is a positive value, which indicates that it is still going north. Okay? 3.2.3. Determine the magnitude of the quad bike's acceleration during the first 6 seconds. Okay? So 3.2.3. To work with acceleration. Now, from a position time graph, we can't jump straight to acceleration, right? From displacement, we can't jump straight to acceleration. So we need to think about the formula for acceleration. Acceleration is equal to the change in velocity divided by the change in time. Or in other words, we can say Vf minus Vi over t. We know that they're talking about 6 seconds. So t is going to be 6. Now let's consider what the velocities were. Do we know these velocities? We know the velocity at 6 seconds. We worked it out. So this is Vf. So 12 minus, and you can see from the graph that it started at 0. The position started at 0, which tells us that the velocity started at 0. So 12 minus 0 divided by 6, and that gives us an answer of 2 meters per second squared. Now remember, they mentioned magnitude. The word magnitude means you don't need to put a direction. Okay, let's move on. Question number 4. In the diagram below, the driver of a car traveling east at a constant velocity of 45 meters per second notices a speed trap 100 meters away. The speed limit is 120 kilometers per hour. The driver takes 0.5 seconds to react before applying brakes. The car slows down uniformly at 6 meters per second squared. Convert the speed limit to meters per second. So this one is quite simple. When you want to convert from kilometers per hour to meters per second, you divide by 3,6. Okay, so 120 divided by 3,6, that is equal to 33.33 meters per second. So that's the speed limit, right? That's the speed limit. So when the car reaches that point, if its velocity is more than 33.33, then the speed trap is going to switch on. Question 4.2. Use relevant calculations to determine if the car will exceed the speed limit at the speed trap. Okay, and when you do a question like this, you have to remember that there is a space of time where the driver of the car is still reacting. Because when the driver of the car sees the speed trap, it still has to register what's actually happening. And in that time, the driver of the car has moved, right? We call that the reaction distance. So let me show that to you. I can sketch it out for you. So if this is the speed trap, and the driver of the car is here, at this point he spots the trap. But some time passes before he actually presses the brake. So, or slows down. And in that time, he's actually moved. He was here, and this is where he's pressing the brake. So this is called the reaction distance. And it's important to remember that in the reaction distance or during the reaction distance, the velocity does not change. Okay, so let's start. First, we can work out the reaction distance. So how far does the driver travel in the time that his brain is still processing what's happening? So we can work out the reaction distance. So the reaction distance let's write it like that. That's equal to v times t. Simple formula, right? How fast is the driver traveling? The driver is traveling at 45 meters per second, and it takes the driver 0.5 seconds to react, which means that the driver in that reaction distance traveled 22.5 meters. So if the driver saw the traffic or the speed trap 100 meters away, in the time that it's taken the driver to react, he's actually moved 25 meters. Which means that the driver only has 22.5. Sorry about that, 22.5. That means the driver only has 77.5 meters left in order to stop, right? So we can say that the distance that's left is equal to 100 minus 22.5, and that's 77.5. Right, so this is the distance value that we need to use now. Okay, so use relevant calculations to determine if the car will exceed the speed limit. Okay, so we want to work out VF. In other words, we want to work out what's the velocity when the driver reaches that point. So we want VF, we know delta x, we know that the acceleration is going to be -6. Now let's consider for a second why it's -6. Because if the acceleration is +6, it means that the velocity is going to increase. The car obviously wants to slow down, so the acceleration should be -6. Okay, so acceleration is -6. We know delta x, and we know the VI. We know that the velocity here is 45 meters per second. So we know that's 45. And remember, if you know three quantities, you can solve anything using equations of motion. We know delta x, we know acceleration, we know VI. Now it's just a matter of what formula do we use. So you look at your formulae, right? And you would then choose VF squared equals VI squared plus 2a delta x. VF squared is what we want. VI is 45, and that's 45 squared, plus 2 into -6, and then the distance that the driver has left is 77.5. And then you solve for VF, and when you solve for VF, you're going to get a speed of velocity of 33.09 meters per second, which tells us that when this driver reaches the speed trap, he's going to be traveling at a speed that is lower than the trap. So will the driver exceed the speed limit? The answer is no. He's not going to exceed the speed limit. Okay, question 4.3. Determine the time taken for the car to reach the speed trap after applying the brakes. So again, let's use let's write down the quantities that we know. We know the VF when he reaches the speed trap is 33.09. We know VI was 45. We know delta x was 77.5. We also know acceleration, which is -6. We have more than enough quantities to work out the time. So to work out time, let's use the first one. VF equals VI plus A delta t. 33.09 equals 45 plus -6 times delta t. I solve for delta t, and delta t is then equal to 1.99 seconds. So in other words, it has taken this driver 1.99 seconds to travel from this point to the speed trap. Okay, and that's it. If you found this video useful, please leave a like. Consider subscribing. If there's something you'd like me to do specifically or some paper, please let me know down in the comment section below. Until next time.